about our next 6-7 videos, we'll be considering integration using trigonometric substitutions. In our last video, we talked about change of limits, and the video before the last, we're talking about algebraic substitution. Now let's talk on trigonometric substitutions. Now these are the forms we'll be considering. We'll consider the powers of sines and cosines. We'll consider integration of product of sines and cosine, product, powers, and we also consider the integration using x is equals to a sine theta and x is equals to a tan theta, as the case may be. So these are the forms. But before we go deep into this, let's look at how to integrate cos square theta, or let's say cos square x, and sine square x, so that we will understand the basics of what we are going to be doing. So let's take an example that we are asked to integrate with respect to t 2 cos square 4t dt. Now, if we go back to our trigonometric identities, we realize that cos 2a is equal to 2 cos square a minus 1. Therefore, instead of using a, I can use t. Cos 2t is 2 cos square t minus 1. So we can make cos square t solve the formula. Therefore, cos square t is equals to 1 over 2 into 1 plus cos 2t. Now, the question says we should simplify, integrate cos 4t. Therefore, wherever we see t, we will substitute t. So that's 1 over 2 into 1 plus cos 2 4t. And simplifying this, we will have 1 over 2 into 1 plus cos 8t. Therefore, we can rewrite this question now in terms of cos 80, so that wherever we see cos square 4t, we will substitute 1 over 2 into 1 plus cos 80. So this becomes 2 into 1 over 2 into 1 plus cos 8t. And then we will have dt. Since the question has been simplified into this, we can now go ahead and simplify further. And this will give us 1 plus cos 8t dt. Now this can be simplified in standard form, because we know that integrating cos 80 dt will give us 1 over a sine 80 plus c, and integrating a constant with respect to t or anyone will give us kt. Let's say the constant is k. If you say the constant is k, then this will give us kt plus c. Now with that done, integrating 1 plus cos 8t will give us t plus sine 8t over 8 plus c. So very important. So if the question was changed from indefinite integral to definite integral, and we are asked to evaluate 0 to pi over 4 of 2 cos square 4t dt. Now we know this integrating to cos square 4t will give us t plus sine 8t over 8 and our limit is 0 to pi over 4. So we can input our upper limit and lower limit, and putting that in, we'll have pi over 4 plus sine 8 into pi over 4 divided by 8 minus into 0 plus sine 8 into pi over into 0 divided by 8. So simplifying this will give us our answer to be pi over 4. Let's consider how to integrate sine square 3x with respect to x. So let's integrate sine square 3x with respect to x. Now, we recall that cos square x plus sine square x is equals to 1. And just like we have done here, that cos square t is equals to 2 cos square t minus 1 cos square, let's now call it cos square x. Cos square x is equal to 1 over 2 into 1 plus cos 2x. Now we can find an expression for sine square x. Sine square x now will be 1 over 2 into 1 minus cos 2x. Now, since the question says we should simplify sine square 3x, therefore sine square 3x will be equals to 1 over 2 into 1 minus cos. We're following this format. So we are changing x into 3x. So wherever we see x, we substitute 3x. So it gives us 1 minus cos 2 into 3x. So this will be 1 over 2 into 1 minus cos 6x sine square 3x. Therefore, we can rewrite this question to give us integral of sine square 3x dx to be equal to integral of 1 over 2 into 1 minus cos 6x dx. So when we integrate this, we have 1 over 2 as the constant both outside. Then we have integral of 1 minus cos 6x with respect to x. So integrate this, we will have 1 over 2 as the constant. And integrating 1, we have x. Integrating cos 6x. Integrating cos 6x, we will have minus sine 6x over 6 and plus c. Now we have seen how to integrate sine square x and cos square x. In our next video, we'll be taking a look at how to integrate higher powers of sines and cosine.